All right, so hopefully you got a few problems done. You were given a couple of minutes to kind of get started on these, so we're just going to go through them together as a little review of the solving equations involving square roots and, of course, the imaginary number, that I, that we talked about over the last 2 days. So with the first one, we need to look at the 7 and the 9. Those two numbers, we call them like terms. They're both outside. So we would want to focus on those first. So when we multiply those two numbers, 7 and 9 give us 63. And then the radical values, we want to multiply those two together as well to give us 24. And then the second step, split up that 24. One of them needs to be a perfect square, which is the number 4. And then we have the square root of 6. So this becomes 63 times 2, because the square root of 4 is 2. The square root of 6 we cannot do anything with. And then the last thing, multiplying 63 and 2 together gives us 126 square root 6. So the second type of problem here, we have a fraction underneath the radical. And when you think about a fraction underneath the radical, you really can think about that as the square root of 50 separate from the square root of 3 instead of the whole thing being underneath the radical. We could split that up. We need to do that rationalizing the denominator process. Whatever square root's in the denominator, we need to get rid of. So we would multiply it by the square root of 3, top and bottom. So the top is the square root of 150. The bottom now just becomes 3. So we can't have a radical in the denominator. We want to rationalize it, which means get the radical out of the denominator. And then looking at the square root of 150, this one's a little trickier. It's 25 and 6. So 25 times 6 makes 150. The square root of 25 is our perfect square of 5. The square root of 6 stays, and then we still have it divided by 3. This is the simplified answer. If we could reduce 5/3, if there was something that would divide into both of those, we would want to do that, but otherwise it's simplified as is. And then the third one here, simplifying the radical. The first thing we need to focus on is get the negative out. You technically cannot simplify it with a negative number underneath the radical. So that's how we get that imaginary number I. So you pull that out, then you think about simplifying 180, which is really 36 and 5. So we have the 36 becoming the 6, the I goes after the 6, and then the square root of 5. So those are 3 little examples reminding you about reducing radicals, simplifying square roots, and the imaginary number. The second set of examples we're looking at are solving equations. So now we're trying to get the quantity that's squared by itself. In this case, we have that quantity x minus 7 squared. So let's get rid of the 10 that's in front of it by dividing it out. Still have x minus 7 squared, but now it's equal to 44. So the quantity that's squared is isolated, meaning it's by itself. This is the time now where we take the square root of both sides, because our goal is to cancel the square and the square root. Those two methods undo each other. Those operations undo each other. And then on the other side, we have the square root of 44. Just like we did in the upper 2 problems, or 3 problems, we need to break 44 down. That would be 4 and 11. Now, because we're solving an equation for x squared, we have a plus or a minus in the answer because there's a left and a right side. So the square root of 4 becomes 2, and then we keep the square root of 11, but we place that plus or minus in front of it. And finally then, let's add the 7 to the other side. So we have a 7, a plus or minus sign, and then 2 square root of 11. And remember, you can leave your answer like this. We do not have to separate it into 2 separate problems because those 2 numbers do not combine. The 7 doesn't have a square root with it, so you cannot add 7 and 2 together. They just stay as separate answers. So the whole number 7 plus or minus 2, and then square root 11. All right, so looking at the second example, we have to move that 8 to the other side first. So take the 8 to the other side. There are like terms that can be combined. We want to combine those like terms first before we do anything else. The next step would be to get rid of the 9. So we want to get it out of the problem, divide it out to the other side, take it over to the other side. Always want to make our numbers smaller. And 449 or 441 divided by 9 seems like it should be an ugly number, but it actually turns out to be 49. Kind of a nice number there. So take the square root of both sides. The square and the root cancel, leaving us with 2m minus 3. The square root of 49 is 7, but don't forget really it's a plus and a minus 7. So now anytime we're solving equations and we're getting rid of a quantity that's squared, we'll always have those two solutions, the positive and the negative, to account for the right and the left side of the parabola. This one we do want to separate because plus or minus 7 does not have a radical with it. It's just an integer, so we'll separate that positive 7 and negative 7 into two equations, and then we would solve these two equations. So you should end up with two different answers here because one was equal to a positive 7 and the other was equal to a negative 7. So we have a positive 5 and a negative 2. So we had two answers in number 1 right next door, but those two answers could not be simplified because of the radical. This time we have two nice answers, two integer values, because the radical did break down to a perfect square of 7. Alright, so let's look at the third equation that's up here. This one we don't have parentheses, so we just need to work on getting that p squared by itself. So it looks like we need to take the 8 to the other side. Oh, nice ugly number there. Negative 23. It's going to give us beautiful answers. So we'll divide the 8 out so that p squared is by itself. Now the only thing we have to do is get rid of the squared term, so we need to take the square root of both sides. And then in this step, I'm also going to pull that negative out. Right now we have the square root of a negative, so we have a plus or minus because we took the square root. Taking the negative number out gives us the I. And then we're looking at the square root of 23 and the square root of 8, which does need to be broken down and rationalized like we did up at number 2. So the square root of 8 can really be the square root of 4 and the square root of 2. So we have plus or minus I, the square root of 23, and then the square root of 8 becomes 2 square roots of 2. So this one was easy to solve. It's the simplifying part that's a little more interesting, I guess you could say. So finally, we have to get rid of that square root that's in the denominator. It's the square root of 2. So top and bottom need to be multiplied by the square root of 2. We cannot have a square root in the denominator. It's considered unsimplified, so we need to rationalize it. So we have the I. We can multiply these two radicals together. 23 times 2 is 46. So plus or minus I square root of 46. And then on the bottom, we have a 2. The square root of 2 times the square root of 2 also becomes 2, so then that would be 4. So you could also write this as plus or minus square root of 46 over 4 with the I behind it, if you prefer to see that I behind it. Either way is acceptable. So that problem, the solving, getting p squared by itself, that was pretty straightforward, but the simplifying was a little more involved. So there are 3 final sets of problems, and that just deals with simplifying the imaginary number. So a couple of problems just simplifying with I, remembering our operations with I. So treat I as if it were an x. It has to combine with a like term. So you can only combine an I with an I when you're adding or subtracting. And in this case, we have a parenthesis there. Really, there's a negative 1 in front, so that negative 1 needs to be distributed through the parentheses. So we have a negative 3 plus 6i. That doesn't change. And then you're taking negative 1 times 5, negative 1 times negative 3i, so positive 3i, and then minus 8i. And and then combining your like terms. So looking at the whole numbers here, or the integers here, we have a -8, combining them together. And then our i's, there are 3 separate ones. So 6 and 3 make 9, minus 8 leaves us with 1. So a -8, that's from the numbers, the numerical values, and then the i's combined to just be I. Number 5 looks exactly like foiling with x's, except there's i's in it, so we can perform the same method with FOIL. So -56, +21i. The middle terms give us +48i, just watch your signs. And then the last term gives us a -18i squared. So the middle terms are both i's, we can combine them together. So we have -56 plus 69i minus 18. And then yesterday we said I squared really is -1, so we can change that to a -1. So that means that we're adding 18, because -18 I squared is really a +18. So when we take that +18 with -56, that makes a -38, and then plus 69i. That I needs to go in the back. That's the standard form of imaginary numbers. So this last one here, again simplifying, we have these 2 i's in the front, so -18i squared. And then distribute the -3 through, +21 minus 18i. Again, we have that I squared, so I squared is -1. So this number here is really a +18, plus 21 makes +39, and then minus 18i. So that was a short little review of the concepts that we were working on Wednesday and Thursday of this week. So rationalizing, working with square roots, solving equations involving taking the square root and radicals, and then of course simplifying with the imaginary number. You're going to be given a review worksheet of those 2 sections, sections 4.5 and 4.6. This worksheet will be collected from you on Monday. An answer key was sent through Remind and also posted to Google Classroom, so please make sure you're checking your solutions, making sure that you have the correct solutions. Always reference that answer key. You need to make sure those solutions are correct. Please feel free to work in partners, but be working. Use this time wisely.